Welcome back to STS. In today's tutorial, we're going to work with a trigonometric equation, and we're going to solve this equation over a specified interval. In this example, that interval is from 0 to 2 pi, where 0 is included and 2 pi is excluded. The trig function we're working with is sine, and we're taking the sine of x minus pi over 4, and that results in 1/2. We need to notice a couple of things. First, we're using the sine function, and second, that the result is positive. So what we're going to do is we're going to draw a basic graph here, and we want to see where sine is positive on our unit circle. And that means that, well, first let's do this. We know that sine of theta is the y values over the r values, where y corresponds to the y length and r corresponds to the radius. So for us to have positive y values, that has to be in the first quadrant and also here in the second quadrant. Alright, next thing we know is that the y values correspond to 1, so that means these lengths here are 1. The radius corresponds to 2, so that means these hypotenuse here are 2. And this resembles the special triangle 30, 60, 90, so we know that this length here has to be negative root 3, and this length here has to be a positive root 3. To figure out the angles, I'm going to call this angle here theta 1, and I'm going to call this angle here theta 2. Well, opposite theta 1 is the value of 1, so that tells me that this length is 30, because again I said this that triangle represents the 30, 60, 90 special triangle. Opposite to 30 is 1, opposite to 60 is root 3, and opposite 90 is 2. So here we know that theta sub 1 is the same thing as 30 degrees, and we know that 30 degrees is the same thing as pi over 6. To figure out the value for theta 2, we know that here at on the axis here is pi, which is 180 degrees. If this angle is 30 degrees, that means this angle here is 150, because 180 minus 30 gives me 150. Now we use some basic mathematics to figure out what the radian measure is going to be. Well, if I take 30 and multiply it by 5, I come up with 150. So I just multiply this radian measure by 5. So pi over 6 times 5 is 5 pi over 6. Now I have the two values for theta that I need to figure out the values of x that make this equation true over the interval 0 to 2 pi. So let's begin. I have x minus pi over 4 is equal to theta 1 plus 2 pi k. I use 2 pi because 2 pi is the period for the sine, and I use the value of k, which is an integer, because that lets me know I have an infinite number of answers as I go around this unit circle multiple times. So now let's solve this equation for x, and let's also substitute in the value for theta 1. So here I have x minus pi over 4. Well, theta 1 is pi over 6, and then plus 2 pi k. I'm going to go ahead and add pi over 4 to both sides. So let's do that there, plus pi over 4. It cancels here, and I'm left with x is equal to pi over 6 plus pi over 4 plus 2 pi k. For me to add these radian measures, they're fractions. For me to add them, I need common denominator. The common denominator is 12. So 6 times 2 gives me 12, so that means I multiply my numerator times 2, so that becomes 2 pi. 4 times 3 gives me 12, so that means I multiply this numerator by 3, so that there is 3 pi, and then plus 2 pi k, and this simplifies down to, well, 2 pi plus 3 pi is actually 5 pi over 12 plus 2 pi k. And if I substitute in a value, let's say k is 0, well, that means this section here, 2k times 0 is actually 0. So I see that when k is 0, my x value is 5 pi over 12. Alright, when k is 1, well, when k is 1, I'm already at 2 pi, and I know that with my interval, 2 pi is excluded, so I know I'm not going to have a value for k equals 1. Now let me go ahead and switch colors, and I want to work with the theta sub 2. So here I have, let's see, x minus pi over 4. I need theta sub 2, so I'm going to put in the radian measure, which is 5 pi over 6 plus 2 pi. Again, sine has a period of 2 pi, and I use the k to substitute in the integers that again say that the integers that signify the multiple solutions as I go around the unit circle. So first thing I want to do is add pi over 4 to both sides. So plus pi over 4. We see the pi over 4 cancels here, and I have x is equal to 5 pi over 6 plus pi over 4 plus 2 pi k. Again, to combine these, I need to do the same thing as far as finding a common denominator, and again, that common denominator is 12. Let me just rewrite everything else. Alright, for the 6 to become a 12, I multiply by 2, so that means I multiply this numerator by 2, so this becomes 10 pi. 4, I multiply by 3 to get 12, so I multiply the numerator by 3 to get 3 pi. Then I do my combination. 10 pi plus 3 pi gives me 13 pi. And again, that's over 12 plus 2 pi k. And I'm going to do the same thing with doing substitutions for k. And I'm going to squeeze that in over here. Let's say k is equal to 0. When k is 0, this term here goes to 0 because anything times 0 is 0. So I say that when k is 0, x is equal to 13 pi over 12. And then when k is 1, well, this term here is 2 pi. And if I add something to that, again, that puts me outside the interval. So again, I see that 13 pi over 12 is one of my solutions, and 5 pi over 12 is the other solution. Let's go ahead and call up the calculator so that we can verify these analytic results graphically. So with the calculator, let's go ahead and press y equals, and you'll notice that I already have the equation, the trig equation in place. For y sub 1, I have the sine of x minus pi over 4, and then for y sub 2, I have the value that that function is equal to, which is 1/2. And now let's press graph. Alright, here we see a graph where the blue is the original, is the sine function, and the red is the constant of 1/2. Let's go ahead and click on zoom, and then go down to 7. So we're looking at it's more trig friendly values on the graph. So we'll let that draw itself in. Again, the blue is the sine function, and the red is going to be the constant of the 1/2. Next, I'm going to press window, and I'm going to restrict this to the interval. The interval that we have, the min x value should be 0. The max x value should be 2 pi. So let's put that in place. And also, you know what, let's go ahead and change the amplitude. Let's make it go from, you know what, we'll keep the amplitude as it is, -4 to +4. And then let's go ahead and graph. Alright, we see the sine function graphed over that period. And now we see we have two intersections. These two intersections signify the solutions to this particular problem. Well, let's do second and then trace so that we can verify those solutions, and let's press 1 for value. If you remember, we said that one of the solutions was 5 pi over 12, so let's put that in. 5 times pi divided by 12, and that should show the little X marker over one of these intersections. So when I press enter, we see that is over that location, and we see the y value is in fact at 0.5, which is the same thing as a half. So 5/10 and 1/2 are the same. And then let's test the other solution, which we said was 13 pi. So let's put in 13 times pi, and that there should also be divided by 12. And then we press enter, and we see that there is at the second intersection. And again, we know that again that's true. Again, as we see, our y value here is also at the 0.5 or 5/10. Alright, that sums up this video by Speller Tutorial Services. Please friend us on Facebook, and also subscribe to that YouTube channel. And as always, thank you guys for watching.